Let's now find out an expression for apparent frequency when a source of sound moves away from a stationary observer. We saw that there are many instances where there would be Doppler effect. Case can be when the source moves or observer moves or both may move together. Basically, what is needed is a relative motion between observer and source. In this case, we'll consider an instance where the observer is at rest. Let this indicate the observer's position, and somewhere there is a source present. Let's assume that the source is at point S1 and it is moving away from the observer speed of v6s. Let the observer be stationary at the point O. Let the distance between the observer and source some point of time be capital L. Now if we start our measurements, that is, if we take an instance where time t is equal to 0, at this point let the source emit a crest. So at time t is 0, crest is emitted. So the crest, the wave would travel like this towards the observer, and let the speed of the sound be called as v. Now this sound, this crest, would reach the observer at a time let us call as t1. This time t1 the time taken for the crest to reach from point S1 to O. This time is given by distance by speed, that will be L by V. This is what is the time taken for the crest to reach. Now from time t is 0, let us take a time called as t, or we'll call it as t0. The t0 is the time period of the wave, which is time taken for next crest to be released. In the meantime, the source would have gone from S1 to some position, let's call as S2. Source has gone from point S1 to point S2, and here it would emit a second crest, call as say second crest. The distance between S1 and S2 would be, the source moves speed of Vs, time is t0, because from time t is 0 to t0, it will travel a distance of Vs into t0, because distance is speed into time. If a second crest is emitted from here, this crest travels a distance of L plus Vs into t0. So the time taken for the second crest to reach the person we call as t2, that would be t0, because we are starting measurements from time t0 only. So from time t0 it will be t0 for the crest, for the source to travel to point S2 plus distance from here, that will be L plus Vs to t0 by V. That is from time t is 0. If we take calculations, then the second crest would reach the person in this time interval. Again, if we look at next interval, next time period, the source would have gone to a point S3. Again, distance from S2 to S3 would be Vs into t0. If at this S2, we call as S3 here, if at S3 a third crest is emitted, now this third crest would reach observer, because observer at rest we call as time t3. So time t3 is the time taken for the third crest to reach. It will be 2t0, because t1 or t2 or t3 is from t is 0 reference only. It becomes 2t naught plus distance now is L plus 2 times Vs into t naught. This is the distance. We want time by speed to give us time. So using same logic, you can say if after time of nt naught, then at the time n plus 1th crest would have been emitted. Yes, at time t is 0, the first crest is emitted. After time t naught, second crest. After time 2 t naught, third crest. After time n t naught, n plus 1 crest would have been emitted. Now this n plus 1th crest would reach in a time interval we call as t. N plus 1 that is equal to, it will be n t naught plus L plus will be n Vs t naught by V. So this is the time interval after the nth plus 1 crest reaches the observer. If we look at difference between Tn plus 1 minus T1, yes, if we take difference of Tn plus 1 minus Tn, this will give us the time interval for which n crest would reach the observer. If we divide this by time, it would give us the time period for which the crest would reach the observer. And that time period will not be same as t naught, because t naught is when it is given by the source, and since source is in motion, the waves would have been expanded because of motion of the source. So this is the time interval for the crest to reach the observer, and we'll call this as t. From here you can say this t is equal to V nt naught plus L plus n Vs t naught by V. This is Tn plus 1 minus T1 was L by V, L by V, the whole under n. Expand this, then what we get from here would be nt naught. Yes, we'll break the terms here. L by V plus n Vs t naught by V minus L by V whole n. This term gets cancelled. So what we get from here would be t is equal to V n t naught plus n Vs t naught by V n. Here n gets cancelled because n is common terms here. Therefore what remains would be t naught, if we take as common, be 1 plus Vs by V. What is t in terms of t naught? But what you want is the frequency. Frequency is 1 by time period. So from here, if you bring it down, this t is equal to t naught 1 plus Vs by V. If you bring it down, then what you get is 1 by t naught into 1 plus Vs by V is equal to 1 by t naught, 1 by t rather. 1 by t would be the apparent frequency, because t is a time interval between two crests being observed by the observer. 1 by t would be apparent frequency. We call as f, say apparent, is equal to 1 by t naught would be frequency of the source, and this term goes on top. So 1 plus Vs by V or minus 1 is what we get. If we assume a case where V is more than Vs, that is the source moves at a very less speed compared with speed of sound, then we can approximate this value here. I think that what we get is, we get F apparent is equal to F naught 1 minus Vs by V. If from a cross multiply or we take LCM, then F apparent is equal to F naught into V minus Vs by V. This is the expression for apparent frequency. The source moves away from the observer. It's common sense that whenever the source moves away from observer, then frequency or stillness will decrease. That is given by this term here. This term would be less than this term. Therefore, it implies that F apparent F naught, which is what is expected. Similarly, if we take a case where instead of source moving away from observer, if this is the observer and if the source moves towards the observer, this is the source moves to the observer, then we can replace Vs with minus Vs because it is opposite to what we took earlier. In that case, the apparent frequency would be equal to F naught V plus Vs by